Hi everybody, in this video we are picking up where we left off and we are verifying a few more trig identities. In the last video I left off on number 43, so I'm going to pick up from there. I'm trying to keep each video short so they're not overwhelming, you know. Alright, this one I would start, oh what am I doing? Where's the light? Sorry guys. I slid the thing over and now it's all messed up. Okay. I would start with the left hand side because there's just more to work with. I have adding, I can find a common denominator and bring it together and likely turn it into something much simpler. So cosine theta plus tan, I'm going to rewrite as sine over cosine times sine theta, and eventually we're going to see that it equals secant theta. Next step, I'm going to take the cosine, which is over 1. I'm going to multiply it on top and bottom by cosine theta. So that means I have cosine squared theta over cosine theta plus sine squared theta over cosine theta equals secant theta. Really, I have a common denom, so I could just write it as cosine squared theta plus sine squared theta equals secant theta. 1 over cosine theta equals secant theta. Don't stop there. Go all the way until you have secant theta equals secant theta, and we're done. Not so bad. Watch it, rewatch it, pause it, rewind it, do what you gotta do. Next. Okay. I'll probably use the left. I think. So I'm already seeing like 45. It's going to be a lot like the examples on the previous page. We saw 2 examples like this already where we would get 1 over sine theta cosine theta, and we would get that 4 times. And it'll come up and it'll be that to the 4th power. It's really kind of redundant, but let's go, okay? Redoing, even though it's just like the other one, so I'll do it on the floor. Basically, if you look at like number 39, right? That became this. That's going to be the inside of the parentheses basically, but theta instead of beta. And then we'll have 4 of them. And sine on bottom is the same as cosecant on top. Cosine on bottom is secant on top. 4th power. And you're done. I just had to stare at it for a few seconds, you know, to think about it. I guess I'll do it. So sine over cosine, which will get multiplied by sine over sine, plus cosine over sine, which will get multiplied by cosine over cosine. All right, and then this is going to keep going down. I'm not going to rewrite it this time. 4th power. Sine squared plus cosine squared over cosine theta sine theta, 4th power. 1 over cosine sine 4. Secant cosecant 4. Secant to the 4th theta cosecant to the 4th theta equals, the other side just had it written the other way. Done. That's it. Kind of cute. I didn't hate it. The next one, I kind of want to change the right side. You could do the left, the same thing in reverse, but let's do the right. On the right side, I'm going to first think of it as cotan squared times cotan squared. Thinking of the Pythagorean identity, which is 1 plus cotan squared theta equals cosecant squared theta, right? If I subtract the 1 over, cotan squared equals cosecant squared minus 1. Cosecant squared theta minus 1. So can you see where I'm going already? going to multiply with distribution, FOIL, whatever. Cosecant squared times cosecant squared is cosecant to the 4 theta. Outer is minus cosecant squared. Inner is minus cosecant squared. So minus 2 cosecant squared theta. And negative 1 times negative 1 is plus 1. Check. Done. Yeah. This one, why do you guys keep getting stuck on this one? Stop. It's one step. Look at it carefully. You have a difference over a sum equals a difference over a sum. These are very common. They're structurally already the same. So all you have to really do is look at the 1. I want the 1 to become cosecant. So I'm going to multiply on top and bottom by cosecant. But while I'm doing that, maybe you think of tan. Don't forget, tan is sine over cosine, but it's also s over c always, secant over cosecant. So secant over cosecant minus 1, because that's tan. Secant over cosecant, and then that's 1, right? And then that's going to multiply, distribute to everybody. When it distributes, it crosses out. You're left with secant minus cosecant over secant plus cosecant. Check. I'm getting lazy. I don't feel like writing it. How many minutes in are we? We're doing good. 6:39. Okay. Next one. Ooh, classic. I love this one. This one's great. Maybe some of you love it by now too. So this one I like to change the left side. This will be 1 over cosine alpha minus sine alpha over cosine alpha all squared. I'm going to be lazy just because it's for a video, and to the end, okay? Here, that's the same as 1 minus sine alpha all over cosine alpha squared. This is the same as 1 minus sine alpha squared all over cosine squared alpha. Top squared and bottom squared. The top squared is 1 minus sine alpha times itself. 1 minus sine alpha. The bottom, cosine squared using the trig identity, Pythagorean identity, is equal to 1 minus sine squared alpha, which is different, not the same as 1 minus sine alpha quantity squared. This can factor using conjugates, difference of two squares, okay? So I'm going to put a little dot for like almost like, or arrow maybe as like a bullet point, okay? So these are the new lines so that they don't blend into each other, okay? So now I'm here. So the bottom, the top is 1 minus sine twice. 1, don't accidentally write plus somewhere, okay? The bottom factors using conjugates, so 1 minus sine and 1 plus sine. These reduce down to 1. And guess what? We're done. Finished. That's it. Check. Need a second? Pause it. Rewind it. There's number 48. 2 more. Can I do them in the next minute and a half? Let's see. Okay. 49. We've seen ones where everything in it was a double angle, so we were able to just ignore it. Here, not everything is a double angle, so you can't ignore it. So we're probably going to want to rewrite. So sine of 2 alpha is 2, or theta. Sine theta cosine theta all over 1 minus sine squared theta equals 2 tan theta. This bottom right here, I should have changed it already. That's cosine squared theta, right? So let's pretend I did that in that step already, okay? Cosine, I can cross out one of them with one of them. That means I'm left with 2 sine theta over cosine theta, which is 2 tan theta. Done. Okay. Last one. Couple ways you can do this. You could get a common denominator, or you could think of cosine squared as 1 minus sine squared beta. Please keep in mind all numerators and denominators have invisible parentheses around them. Okay, some of you guys like I don't know where you missed that bus. You missed that memo. That numerator is 1 minus sine theta, beta, whatever the heck it is, 1 plus sine beta, all over, when I factor it, 1 plus sine beta, that and that are gone. 1 minus the quantity of 1 minus sine beta equals sine beta. Distribute 1 minus 1 plus sine beta equals sine beta. Gone. Sine beta equals sine beta. Check. So in all of these, I only ever changed one side of the equal sign, as should you. There's more than one way to do it. Just because you did it differently doesn't mean you're wrong, but it is possible that you got lucky and you are indeed wrong. Because sometimes you lie. Okay? Questions, comments, concerns, requests, whatever, in the comment section. Thumbs up. Check the next video. Go to the playlist. Bye for now.